Okay, these are your 2.5 notes on adding and subtracting polynomials. We are going to add and hold on. We're going to add and subtract polynomials, obviously. And then we're also going to classify polynomials by degree. Okay, we'll talk about degree in a little bit. I don't want to get ahead of myself. So, what the heck is a polynomial? Well, this is an example of a polynomial. A polynomial, if you look at the word polynomial, poly means many. And nomial comes from Latin, okay? It has to do with names or terms. So this part means terms. So it's got many terms added together, right? So you can see this one has 1, 2, 3, 4 terms. Okay, the terms are separated by the addition and subtraction operators, the plus and minus signs. So these are your terms. Okay, let's talk about what's in terms. These numbers in front of the variables, you might recognize them. They are coefficients. Coefficients has the part like co in that, which means with. Oh my gosh, my face. With the variable. So the coefficients are with the variable. All right, this little one at the end that doesn't have a variable, he's all alone. Okay, he's a constant. That's our constant term. Okay, so if he doesn't have a variable with him, he can't vary. He's just always going to be 1. He's always 1. He's very, very boring. He's constant all the time. Okay, that's 1, constant. We have some other fun little numbers in here. We've got a power of 3, a power of 2, and a hidden power of 1. Okay, those are your exponents. Okay. And last but not least, raised to the power, we have our variables. So those are some of the nuts and bolts that make up a polynomial. Easy enough, right? All right, next thing we need to talk about is standard form. So we know that a polynomial is in standard form when its exponents are in descending order. So the example that we just dissected up at the top, that one is in standard form. The exponents go 3, 2, 1, none. So they're going down, they're decreasing, that's standard form. Okay. So example 1 tells us to write this polynomial in standard form. So we have to start with the term with the biggest exponent. So I see this positive 5x to the 4th has the biggest power, 4. So I write that first, 5x to the 4th. Okay. Then I look for the next highest power. It's negative 2 x to the 3rd. So the 3 is the next highest power. So I write him next. Notice that I keep the negative sign in front of the 2. Don't drop the negative sign. It has to stay with the 2. That is part of that coefficient. All right, next is the negative x squared. And last, the plus 6. Okay, so we skipped over a term with x to the power of 1, but we didn't have one in our polynomial, so that's fine. We can skip over powers if we don't have them. They just have to be going down the whole time. Okay. Now we're going to classify polynomials by degree. Now, I told you I would tell you what degree was in a minute, and that minute has arrived. Degree is going to be your biggest exponent. So if I look at my first polynomial, my biggest exponent is this 4. So I say that the degree is 4. And any polynomial with a degree of 4, we have a certain name for it. Its classification is quartic. It's Q, not G. Quartic. Now, hopefully you can see, oops, we got a quart in there. That should remind you of like a quarter, right? We got 4 quarters in a dollar. We got 4 quarters in a basketball game. 4 quarters in a dollar. Bottom line, quart has to do with 4. So that should help you remember that 4th degree is quartic. So the classification is quartic. This is just a little hint to help you remember the classification. All right, next up, if your highest power is 3, your degree is 3. Okay, 3rd degree is cubic. You might see the word cube in there. There are 3 dimensions in a cube. Okay, these names are not accidents. They come from like words that have meaning to us. All right, the next one, you can see there's something wrong with it. It's out of order. The highest power is 2, but it's not the leading term. So we want to change the order and write it in standard form. So I'm going to put the 7x squared first, and then the plus x, and then the plus 5. Okay, we want standard form always. So my degree is 2. Okay. Now, in your legs, in your thighs, like above your knees, you have 2 quads. Those are those big muscles right there. So these are quadratic. Okay. And to help you remember, you have 2 quads. Okay. If you have more than 2 quads, you should see a doctor. All right, next. This one has the invisible power of 1. It's not written in there, but we know it's there. So its degree is 1. Okay, this one is called linear. Now, in the word linear is the word line. You see it? Look at this. Doesn't it look like y equals mx plus b? Like I could write y equals 9x minus 10, and it looks like the equation of a line. Okay, we'll find out in units 3 and 4 that this would be the equation of a line. It's like part of the equation of a line. This is a linear pattern. Okay, it's going to have a constant rate of change. So this one, linear, is like a line. Okay, last but not least, if you're looking at this pattern, you're going to see it goes 4, 3, 2, 1, none. And then you're going to look at this 4 and you're going to say 4 has a power of 1. What the heck? Right? Well, if you look at all of the other powers, it's x that's going to the power, x to the 4th, x to the 3rd, x squared, x to the first. All right, so what we really have here, even though 4 is to the 1st power, it's the x that is to the 0 power. Yes. And we know that anything to the 0 power is 1. So this is actually 4 times 1, which is just 4. Okay, so there is a 0 power there, but it's not on the 4, it's on the x, and that's why we don't even see the x, because the x to the 0 is 1. So this one, we already talked about him up on our anatomy of a polynomial when we talked about the 1 at the end. This one is a constant. Okay, he doesn't have a variable, so he doesn't vary. He's constant all the time. Okay, doesn't vary because there's no variable. Stays the same. All right, let's go over some fancy words for operations. Okay, we know product is fancy for multiplication. We know quotient is fancy for division. We've talked about those a lot. What we haven't talked about so much in this unit yet is the sum and difference. Sum is fancy for addition, and difference is fancy for subtraction. So now we are getting to the adding and subtracting part of the notes for polynomials. You're going to like this. To calculate a sum when you're adding polynomials, all you have to do is combine the like terms. It is so nice. Combine like terms. Okay, so in earlier units, we just said, okay, if it's a constant and it doesn't have a variable, we can combine them. That's the same. And if it's got an x, we can combine them. But now we've got x's with different powers. So when we combine our x's, we have to make sure that it's not just x's we're combining x's that have the same powers. So the like terms have the same powers. All right, so when I look at example 2, I only see one term that has a power of 3. That one right there. So I don't have anything to combine with him. I write him by himself. So that'll be 5x cubed all alone. Okay, next I look for my second degree terms with a power of 2. And I have plus 2x squared and minus 4x squared. What I'm going to do is keep the power. I'm going to keep the x squared part. All right, and I'm going to just combine my coefficients. I'm going to do 2 minus 4. Those are my coefficients. 2 minus 4 gives me negative 2. That's all I have to do. All right, next I have but one linear term, just a lone x. So I write him in there. And then last but not least, I have a negative 3 and a positive 3 for constants. Negative 3 and positive 3 cancel, so I don't have to write anything. Constants cancel. Guys, that's it. This one's done. Stick a fork in it. All right, now we get to talk about perimeter. If I told you to go to the perimeter of the room, you'd go off to the side because the perimeter is all the sides added together, right? So to find the perimeter, we just have to add all sides. Okay, so the cool thing about a rectangle is that its opposite sides have the same length. So if this side is 2x minus 3, so is this side. Okay, if the top of the rectangle is 3x cubed plus x plus 10, so is the bottom. Now, to find the perimeter, all I have to do is combine my like terms around the entire thing. So I'm going to start with my highest degree terms, which are my quadratic terms. Use that vocab. I have 3x squareds for a total of 6. So that'll be 6x x squared. Next, I'm going to add up my linear terms. So I've got a 2x and another 2x. I'm not going to use a box. I'll use a little triangle. 2x and another 2x, and then an x and an x. So 2 and 2 is 4, and then another 1 and another 1. That makes 6 x's. Okay? All right, last constants. I've got a 10 and another 10 to make 20, and then I have to subtract 3. 20 minus 3 is 17. Subtract 3 again, I'm at 14. That's it. That's the perimeter. Okay, moving on. To calculate the difference, guys, it is basically the same thing with one big exception. Before we can combine like terms, we have to distribute a negative. And then we can combine like terms. Okay, I'm going to use the rest of this box to show you why. Hold on. Okay, so I just told you I was going to tell you why we have to distribute a negative. So imagine that we are doing 10, we're finding the difference of 10 and 6, right? So we're doing 10 minus 6. Well, unless you fell out of a tree and then hit your head on a rock, you know that's 4, okay? So 10 minus 6 is 4. Now, we also know that 6 is like 5 plus 1, right? So I can rewrite this as 10 minus 5 plus 1, and I should still get 4. I'm being sneaky here. If you look at it, it says 10 minus 5, which is 5. And then if we add 1 back, plus 1, we're at 6. And 6 is not 4. So what's missing here is a grouping symbol that tells us we're subtracting the whole thing, 5 plus 1. Okay, what I'm missing is parentheses around my 5 plus 1. Okay, because that means I'm taking away the whole 6. Okay, now what happens is that I'll have to distribute that negative. So I'll have 10 minus 5 minus 1, and now I get 4. So if you look at this 5 plus 1, it kind of looks like a polynomial, even though it's just two constants. You can imagine that that's what's happening with a polynomial. If I'm taking away a whole polynomial, I'm subtracting the entire thing. So I have to distribute a negative to the entire thing before I can subtract. Okay, so that's what we're going to do. Here goes nothing. We find the highest power, which is a cubic term. It's got a power of 3, and I write that down because I don't have anything to combine with it. Next, I look for my second degree terms. There's one, there's another. Whoops! Guys, I told you we were going to have to distribute a negative, and then I forgot to do it. So difference means that we have to subtract. Okay, so what I like to do so that I don't have to rewrite this a bunch of times is put my parentheses around my second polynomial because that's the one I'm taking away, just like I did with the 6, the 5 plus 1. And then I turn the and into a big old negative sign. Okay, and then I distribute that negative. So everything in the parentheses goes to the opposite sign of what it was. So I write down my first polynomial, 7x cubed plus 4x squared minus 3. Nothing changed. And now I have to distribute that negative. So instead of positive 2x squared, I have negative 2x squared. Instead of positive x, I have negative x. Now this is the weird one because we're subtracting, so we think it should all be minus. But if I take away a negative, it's actually adding 4. because minus a negative 4 is positive. Okay. Now we combine like terms. Whew, got ahead of myself. All right, so 7x cubed. Next, look for the quadratic terms with a power of 2. I have 4x squared minus 2x squared. That gives me 2x squared. Next, I look for my linear terms. I've got a lone negative x minus x, and then I combine my constants. I've got a plus 4 and a minus 3. That gives me a plus 1. And we're done. All right, let's look at example 5. Now, we know what to do with this last chunk. We know that we're going to have to distribute that negative. But what the heck do we do with these other parentheses? They're just hanging out. Do we have to do something? Let's figure it out. In front of these parentheses, the first two sets, there is a positive 1, not a negative 1. And when we distribute a positive 1 in front of both of these, okay, nothing changes. The signs don't change. The coefficients don't change, because anytime we multiply anything by 1, it just stays the same. So we don't even need those parentheses. So we're going to rewrite it without them. We've got 3x cubed plus 2x plus 5x squared minus x. That part, we just don't even need the parentheses. Now I'm going to distribute my negative. It's a negative 1 if you like to think of it as negative 1. It'll be negative 2x squared, and then a negative times a negative makes a positive 3. Okay. Now I do the same thing. I look for my highest degree first. If you always do them in highest to lowest order, your answer will always be in standard form by the end without you having to take an extra step to rearrange it. Okay. So we're always going to start with the highest one first. So that's 3x cubed. Next, I look for my quadratic terms. I've got a 2x and whoops, that's not quadratic. This one's quadratic. 5x squared and the negative 2x squared. That makes a 3x squared. Now I look for my linear terms that have a power of 1. I have this one and this one. 2x minus x, that's just 1x. And finally, I don't have anyone to combine with my little 3 constant at the end, so I just write the 3 down. That's it. Okay, let's talk about perimeter again. So, given this perimeter, I have to find the missing side. So they're telling me that the sum of all of the sides is 30. Okay, and I have to figure out what that last missing side is. So let's figure out what these are added together. 8 and 12 is 20, plus 5, this is 25 so far. So far we got 25 units and we need 30, so the missing side has got to get us 30. It's got to be 5. Hold on, guys. My computer's being dumb. Okay, we're back. So that wasn't too bad. Next one. I've got another triangle, and this time I gave you linear terms and constant terms, but we're still going to do the same thing. I'm asking you to find the missing side, but I gave you a perimeter. Can't we just add up these sides and see what we get and see what we're missing? So 7x and 10x make 17x. 5 and 5 make 10. Okay, I've got 17 x's, but I need 20. Okay, so I've got to add 3 more x's. Okay, I've got 10 constant for a constant, but I need 13, so I need to add 3 more. This is the missing side, 3x plus 3. All right, guys, we are almost done. All right, level up. Okay, we gotta figure out what the sum of these is. So 30x squared plus 10x squared, that gives us 40x squared. I don't have anything to combine with the 4x, so I just write that one down. And then 3 and 2 make positive 5. Okay, so adding up to my total, I already have 40x squared. I need 40x squared. I don't need any more. Okay, so my missing side does not have a quadratic term because I already have all of my 40x squareds accounted for. Next, I'm going to look at my linear terms. I have 4x, but I need 10, so I'm missing 6. So I need 6x on my missing side. Okay, last we look at the constants. Okay, I have a 5, but I need 6. It's going to take me one more to get there. Okay, I want you to do the last one. Pause the video. Okay, I don't know why I just stared off into space, but it's too late for me to fix it. I didn't know what I was doing. Okay, so we'll talk about it if you didn't do it already. Hopefully you paused the video and did it. So we're going to add these two up. I get 4x squared. 5x minus an x gives me 4x. And then 8 minus 2 gives me 6. Okay, so I have 4x squared, but I need 5. So I need an x squared. Next, I have 4x and I need 4x, so I don't need any more x's. We're good in the linear terms department. Next, I have 6, but I need 10, so I'm going to have to add 4 more. That's my missing side. Okay, sorry that I stared off into space. I haven't had my tea yet. Okay, bye.